today I will discuss introduction of chromatography. In this, I will discuss different definitions of chromatography and also numericals, formulas required to solve the numericals. So first thing is stationary phase. Definition of stationary phase. Stationary phase is a liquid or solid phase of the chromatography in which materials to be separated or selectively adsorbed. Mobile phases. Mobile phases, it moves through, it carries the material to be separated along the stationary phase. Retention time, it is the sum of the time spent in stationary phase and mobile phase. It is calculated as the time from injection time to the detection time. Factors which influence the retention time are gas or liquid flow rate, temperature differences in the overend column, and column length. Normal phase chromatography and reverse phase chromatography. Colo. In normal phase chromatography, stationary phase is polar and mobile phase is non-polar. Types of the stationary phases used in normal phase chromatography are silica. In normal phase chromatography, least polar compounds elute first and most polar compounds elute last. Because polar components are adsorbed or attracted or have more affinity towards the stationary phase. Mobile phase consists of non-polar solvents such as hexane or heptane mixed with isopropanol. Reverse phase chromatography. The introduction of the technique using alkyl chains covalently bonded to solid support creates hydrophobic stationary phase. It has more affinity for the hydrophobic compounds. The use of hydrophobic stationary phase can be considered as reverse of normal phase chromatography. So in reverse phase chromatography, stationary phase is non-polar and mobile phase is polar. Retention time, the time between sample injection and detection is known as retention time. Retention factor or capacity factor. This is important for solving numericals. Retention factor, the formula is TR minus TM divided by TM. Chromatogram, if a detector that responds to solute concentration is placed at the end of the column, its signal is plotted as a function of time. So it is the plot of signal versus time. Series of peaks are obtained. So this is known as chromatogram. This is an example of chromatogram. This is signal and time. Signal is taken on y-axis and time is taken on the x-axis. So retention time is calculated. Time the solute spends in the stationary phase divided by the retention factor is calculated by using this formula. Time solute spends in the stationary phase divided by time solute spends in the mobile phase. So this is difference of TR minus TM. TR is the time for the retained species and this is the time for the unretained solute. This is the time for the analyte, time taken for the analyte. And TM is the time taken for the unretained solute or non-retained solute. TR minus TM divided by TM. Second one is symmetry factor or tailing factor. Second formula for numericals. So symmetry factor, tailing factor is calculated by using this formula W by 2F. So W is the peak width at 1/20th of the peak height. This is peak width W. This is F, small f. Distance between the leading edge and the vertical. When a vertical line is drawn from the peak top, dissects the horizontal line at 1/20th of the peak height above the baseline. The distance along the horizontal line from the leading edge of the peak to the vertical line. So this is leading edge and this is the vertical. The distance between leading edge and vertical is small f. The formula for symmetry factor is W by 2F. Asymmetry factor is calculated by using this formula BC by BA, BC by CA. At 10% of the peak height, simply you can write as B by A. B is distance from the point at peak midpoint to the trailing edge and A is distance between leading edge and the midpoint. So this is small b, distance from the peak midpoint to the trailing edge. Distance between leading edge and the vertical is the A. Different standard, the substance prepared for use as a standard in assay or identification is known as the reference standard. For new drug substances, reference standards are used. These reference standards, impurity should be adequately identified and controlled. Working standard, materials used for daily use in instrumental analysis are known as working standards. They are characterized by comparison with primary standard. Resolution, formula for resolution is 2 multiplied by TRB minus TRA divided by WA plus WB. Signal to noise ratio, signal refers to the response produced by the analyte, whereas noise refers to the signals produced by the impurities. Selectivity factor is calculated by using this formula alpha is equal to Kb by Ka. Kb is distribution constant for strongly retained species. Ka is distribution constant for less strongly retained species. Alpha is equal to TRB minus Tm divided by TRA minus Tm. Kb is a capacitive factor, distribution constant. This is about introduction for the chromatography. Next, I will discuss gas chromatography. Important questions from this topic are detectors used in gas chromatography and stationary phases used in gas chromatography. Detectors and stationary phases used in gas chromatography. So gas chromatography is an analytical technique. It is used to separate and detect the chemical components of a sample mixture to determine their presence or absence and quantities. Gas chromatography is of two types, gas solid chromatography and gas liquid chromatography. In gas solid chromatography, solid is the stationary phase and gas is mobile phase. In gas liquid, also called as GLC, liquid is the stationary phase and gas is the mobile phase. Gases used are helium, argon, and nitrogen. Important question for 1 mark. Stationary phase used in gas chromatography is polysiloxane. There are two types of columns in gas chromatography, and these are the different components of the gas chromatograph. One is carrier gas supply, flow meter, injector port, column, detector, thermostat to maintain the constant temperature, thermostat, detector, and recorder. Carrier gas. Carrier gases used are nitrogen, helium, argon, and carbon dioxide. Sample injection system. Sample is injected with the help of the syringe needle. Columns. As we discussed, there are two types of columns, packed columns and capillary columns. In packed columns, glass or stainless steel coil is present and it is filled with the stationary phase. Contains the packed columns are filled with finely divided support material. Example is diatomaceous earth, which absorb the liquid, which is used as a liquid stationary phase. Most packed columns length is 1.5 to 10 meters and internal diameter is 2 to 4 millimeters. Capillary columns, there are two types. One is wall coated open tubular column. Second one is support coated open tubular column. In wall coated open tubular column, capillary tube is present that is coated with liquid stationary phase. In support coated open tubular column, first the inner walls of the tube are coated with the solid and onto the surface of the solid liquid is coated or stationary phase is coated. You can see. So this is the tubing. Support coated open tubular column. Inner wall is lined with a thin layer of support material such as diatomaceous earth, onto which stationary phase is adsorbed. Solid support for packed column. The solid support should be small, spherical, and uniform particle size, and should have good mechanical strength, and it should be at elevated temperatures. Stationary phase used in column should be low volatile, highly thermostable, and chemically inert. Thermostat, it allows an increase in the high temperature of the column in increment, thereby allowing elution of all compounds of the mixture within a reasonable time period. This sample. Injection port. From the injection port, the sample is reaching the column and the sample is carried by the gas to the detector. Carrier gas supply, sample injection, column, detector, amplifier, and recorder. So there are 3 detectors are given in your syllabus. First one is thermal conductivity detector. Second is electron capture detector. Third is flame annihilation detector. This question is very, very important. Practice the questions. So you have to practice the diagram for the thermal conductivity detector. So this is the diagram for thermal conductivity detector. The principle is based on the Wheatstone's bridge principle. So there are 4 resistances, R1, R2, R3, R4. Carrier gas is allowed to pass through this R1 and it passes through the column and it reaches R4 and goes out. Only carrier gas passes through the column, then the bridge remains balanced. But when carrier sample is injected, there is change because of the difference in the capacity of the solute and carrier gas to absorb the heat. So there is thermal conductivity difference. So there is a change in temperature. It changes the resistance. So and hence the current in the circuit. Mixture is passed through the column, whereas only carrier gas is passed through the coil A. Mixture is passed through coil B. Mixture contains both carrier gas and the sample. So now the temperature of the coil B depends upon the thermal conductivity of the mixture. So the temperature of the coil B changes and hence resistance R4. Advantages of TCD. Advantage is TCD is simple and inexpensive, non-destructive to the sample, gives accurate results. Disadvantage is it has low sensitivity. Detection of the organic compounds using nitrogen or CO2 as carrier gas is less sensitive. Next, flame annihilation detector. Here the principle is when proper voltage is applied to electrodes, then all the ions will be collected so that the final current is proportional to the number of ions. How the ions are produced? When the sample is introduced into the flame, ions are produced. So the number of ions is proportional to the sample concentration. So that is the principle of flame annihilation detector. Study the working also. Here the limitations are it destroys the sample. And also if there is a heteroatom like oxygen, then it decreases the detector response. That is second limitation. This is most sensitive gas detector. Picogram to femtogram range can be estimated. These are advantages and these are limitations. Diagram of flame annihilation detector. Next, electron capture detector. It contains electron emitter. The electron emitter is a beta emitter, such as nickel or tritium, which is adsorbed on the platinum or titanium foil. 2 electrodes are present, cathode and anode are kept on either side of the beta emitter. 2 electrodes are connected to an ammeter to record the current produced in the circuit. The effluent from the column is passed. So from the column, the effluent is passed over the beta emitter. So the effluent contains both carrier gas and the sample. When solute is not eluted, then only the carrier gas passes over the beta emitter. The beam of electrons causes ionization of the carrier gas, and hence the ions are produced. Ionization results in the production of electrons and ions. Absence of organic solute in the eluate, ionization of the carrier gas produces constant standing current between the pair of electrodes. So when there is no analyte, So the ionization of carrier gas produces a constant current. But when analyte is present, analyte captures the electrons, so the number of electrons decreases, and hence the current decreases. The decrease in current gives an idea about the concentration of the analyte. Advantages: it is selective in response, it is highly sensitive towards the organic compounds, it does not alter the sample significantly, it does not destroy the sample, I can say. Disadvantages: the response in the electron capture detector is non-linear. So this is about detectors. Important questions from gas chromatography are columns and detectors. And from introduction of the chromatography, you have to practice the numericals, formulas for numericals, like symmetry factor, asymmetry factor, resolution, number of theoretical plates, capacity factor, and also definitions of normal phase chromatography, reverse phase chromatography, gradient elution, and isocratic elution. Thank you.